All right, Honors Chem, today we are going to put these the assigning of the oxidation numbers, we're going to put that to practice, and we're going to look at it, how it looks in an equation, a balanced chemical equation, so that we can see what oxidation numbers are changing and the direction that they change, whether we're losing electrons on an atom or gaining electrons on an atom. If we're losing electrons, we're oxidized. If we're gaining electrons, we're being reduced, so that we can see which elements in these reactions are oxidized and reduced. So here we go. We've got our first example. We've got sodium and we've got chloride getting together to make sodium chloride. Now remember, anything that's in the elemental state is going to have an oxidation state of 0. So that means sodium in the elemental state and chloride, as we see it as Cl2 in the elemental state, are going to have oxidation states of 0. Now that's going to definitely change as we get into the compound. When we look at sodium chloride, it's an ionic compound. Sodium gives up that one electron to become a positive 1, and chlorine accepts that one electron to become the chloride ion to have a charge of negative 1. So the thing that we really want to pay attention to is who's losing electrons and becoming oxidized, and which element is gaining electrons and becoming reduced. Okay? So if we look at this, sodium lost an electron, right? So sodium got oxidized. So the substance oxidized is sodium. Okay? Chlorine, on the other hand, gains electron to become a negative 1 charge. So because it gained an electron, the chlorine is what is reduced. Okay? Now remember, oxidizing agent is what helps something get oxidized. And the oxidizing agent is the compound or the element that was reduced. So what was reduced? Chlorine. So chlorine is the oxidizing agent. And the reducing agent is something that helps another thing gets reduced. So that's usually the compound wherein the atom that was oxidized is, or if it's just an element like this, it's just the element. So it will be sodium. Okay? All right. Number 3, let's assign the oxidation numbers. Okay? Remember, elements are 0. So iron is going to be 0 because it's elemental. Oxygen, O2 is elemental, but we've got iron. It's iron 3 oxide. Now let's do this mathematically. So oxygen is our more electronegative element here, so we're going to assign it a negative 2. And I've got 3 of them, so that gives me a negative 6. Remember, we did this when we did ionic compounds. So that means the iron altogether has to be a positive 6. I've got 2 of them, so 6 divided by 2 is a positive 3. Okay? So iron goes from a 0 to a 3. That means it has lost 3 electrons. Losing electrons is oxidized, so iron is what gets oxidized. Now, do you see why they call it oxidized? Because it partnered up with oxygen. That's where the original meaning of the word came from. The substance that got reduced, gaining electrons, is reduction. So oxygen gained electrons, so it is reduced. The oxidizing agent is the compound that got reduced, so that is oxygen. And the reducing agent is the compound that got oxidized, so that would be iron. Okay? All right, let's do a couple more examples. This one's a little bit more complicated. First, we've got to do our assigning of our oxidation numbers. So take a minute, assign your oxidation numbers, and then come back and check. Okay, did you get +3 for iron here and -2 for your oxygen? Hopefully. And +2 for your carbon and -2 for your oxygen here? So far, so good. +2 for iron, -2 for your oxygen here, and -2 for your oxygen here, and +4 for your carbon here. Okay, so now we've got to see what elements changed their oxidation state. Notice in this whole equation, oxygen is always a -2. So oxygen did not change at all. So we can just ignore oxygen here. But iron sure changed. It went from a +3, to a +2. How do I go from a +3 to a +2 with just electrons? I gained an electron, right? Gaining an electron is reduced. So the substance that was reduced here would be iron. Iron's reduced, okay? Now, carbon, on the other hand, goes from a 2 to a +4. It lost 2 electrons. So carbon is what is oxidized. Now, this is where it's tricky. The agent now, we actually have compounds that these elements reside in. So what is the compound that iron resides in? That is the agent. Okay, so the oxidizing agent has whatever was reduced in it. So the oxidizing agent is going to be the whole compound of iron 3 oxide because it has that iron in it. And the reducing agent has the carbon in it with carbon monoxide. So the reducing agent is going to be carbon monoxide. Okay? All right. Let's do example 5. Take a minute, assign your oxidation states. Okay. Are you ready? Okay, copper. This copper is +2. This nitrogen is +5. Oxygen is -2. Okay. Sodium here is a +1. These oxygens are -4. So let's see, that will give me -8 right here. And this will give me a +3. So that means that the phosphorus has to be a +5 right here. Okay, so here I've got -2 and I've got a +5 and I've got phosphate is a -3, right? So I've got 2 of those, so the -6. So that means the copper has to be a +2. And then sodium is a +1. Oxygen's a -2. That means that the nitrogen is a +5. Okay, so how did your assignment of the oxidation numbers go? Did you get them? Okay, now let's look. Is anything changing? Copper, here's a +2. It's a +2. Nitrogen's a +5, and here it's a +5. Oxygen, -2. It's a -2 here, -2 here, -2 here. Sodium's a +1. Sodium's a +1 here. Phosphorus is a +5. This is a +5. Nothing changed. So do we have redox going on? Remember, oxidation is the loss of electrons. Nothing lost electrons. And reduction is the gain of electrons. Nothing gained electrons. So we actually don't have any redox going on here at all. So this is not a redox equation at all whatsoever. Okay, so when we have nothing changing oxidation states, not a redox reaction. Okay, in fact, we have just a double displacement reaction here. All right, example 6. So our oxygen here, let's assign oxidation states, -2. That means that the manganese has to be a +7 here. Hydrogen is already a +1. You see it right there. Oxygen's a -2 here. Hydrogen's a +1 here. That means that the arsenic here, let's see, 6, is a +4 for the arsenic. Manganese here is a +2. It's already labeled. Oxygen here is a -2, both places. So the hydrogen would be a +1. So let's see. That would mean the arsenic here is a +5. Okay, how'd you do on your assigning of the oxidation states? Okay, next we've got to see what changed. So what did change? Hopefully your eyes see that manganese changed from a +7 to a +2. Okay, so how do I go from a +7 to a +2 with just electrons? I have to gain 5 electrons. Okay, remember, reduction is gaining electrons. So gaining electrons is reduction. So what was reduced? Manganese. Okay, the arsenic went from a +4 to a +5, so it lost an electron. So the arsenic was oxidized. Losing electrons is oxidation. Okay, the oxidizing agent has the thing in it that was reduced. So what has the manganese in it? The permanganate ion. So the oxidizing agent is going to be the permanganate ion. The reducing agent has the substance that's oxidized in it. So what was oxidized? The arsenic. So we have arsenic acid here. So that is the reducing agent. All right, so hopefully this made sense, and we'll learn how to balance equations with this next time. Have a great night. I'll talk to you later. Bye.